Good morning. Our topic is alternative energy, specifically solar and wind energy. I will be discussing its significance as a power source, give an overview of the different technologies, as well as its relevance to engineering design and practice. The major advantage of solar and wind energy is that they are both abundant, clean, and renewable energy sources. According to the U.S. Department of Energy, the energy from sunlight that hits the Earth's surface in an hour is enough to power the world's energy consumption for a year. Distributed wind energy is already deployed in all 50 states and accounts for 30% of the country's newly installed generating capacity. There are two main ways to generate electricity from the sun: photovoltaic and the concentrating solar power. Photovoltaic, also known as PV, uses solar cells to convert sunlight directly into electricity. The concentrating solar power, CSP, uses mirrors to concentrate sunlight to heat a fluid that produces steam to power a generator. Here's a short video from the U.S. Department of Energy explaining how photovoltaic cells work.
Alright, we all know that the sun's energy creates heat and light, but it can also be converted to make electricity, and lots of it. One technology is called solar photovoltaics, or PV for short. You've probably seen PV panels around for years, but recent advancements have greatly improved their efficiency and electrical output. Enough energy from the sun hits the Earth every hour to power the planet for an entire year. Here's how it works. You see, sunlight is made up of tiny packets of energy called photons. These photons radiate out from the sun, and about 93 million miles later, they collide with a semiconductor on a solar panel here on Earth. It all happens at the speed of light. Take a closer look, and you can see the panel is made up of several individual cells, each with a positive and a negative layer, which create an electric field. It works something like a battery. So, the photons strike the cell, and their energy frees some electrons in the semiconductor material. The electrons create an electric current, which is harnessed by wires connected to the positive and negative sides of the cell. The electricity created is multiplied by the number of cells in each panel, and the number of panels in each solar array. Combined, a solar array can make a lot of electricity for your home or business. This rooftop solar array powers this home, and the array on top of this warehouse creates enough electricity for about 1,000 homes. Okay, there are some obvious advantages to solar PV technology. It produces clean energy, it has no emissions, no moving parts, it doesn't make any noise, and it doesn't need water or fossil fuels to produce power. And it can be located right where the power is needed, in the middle of nowhere, or it can be tied into the power grid. Solar PV is growing fast, and it can play a big role in America's clean energy economy. Anywhere the sun shines.
Photovoltaic material release electrons when hit by sunlight. There are four basic types. Silicon is the most common. It's efficient and long-lasting. It lasts up to 25 years. The second type is the thin film PV. The thin film PV is applied to either glass or a metal substrate, and there are two subtypes. There's the cadmium telluride. It's the second most common next to silicon. It's cheap to produce, but not as efficient. The second subtype is the copper indium gallium diselenide, CIGS. It's expensive to produce, but more efficient. The third is the organic PV, or OPV. It's made of carbon-based polymers. It's 50% less efficient as silicone, but is much cheaper to produce. And the fourth type is the concentration PV, or CPV. It uses one of the other substrates and uses mirrors and lenses to concentrate light onto the PV cell. It's much more efficient, but is much more expensive to build and implement. Concentrating solar power is designed for a larger power output. There are three main types: linear concentrator systems, dish engine systems, power tower systems. Linear concentrator system focuses light energy to heat a fluid that drives a turbine or generator to produce produce energy. The parabolic throttle and the Fresnel reflector use their mirrors to reflect light to focus it on a tube filled with the fluid that powers the generator. Dish engine systems consist of a solar concentrator and a power conversion unit. The solar concentrator is a parabolic dish that focuses light energy to the power conversion unit. The power conversion unit contains fluids that is heated to drive a generator. These are designed for a portable and modular, and they produce between 3 to 5 kilowatts of power. Our tower system consists of the heliostats and the receiver. The heliostats are mirrors used to focus light energy onto the receiver. The receiver also contains a fluid that is heated to drive the turbine generator. The largest solar power tower produces 292 megawatts. There are two main ways to generate energy from wind. There's a vertical axis rotor and there's a horizontal axis rotor. Vertical axis rotors are easier to design and maintain, primarily because the gearbox in the generator is at ground level. They have a slower rotation speed and they're not as efficient as horizontal axis rotors. The horizontal axis rotors are more complex to design and maintain. The gearbox in the generator is suspended high up in the air. They have a higher rotational speed and they benefit from more advanced rotor designs taken from the aerospace industry. This is an example of vertical axis rotor. It's known as the Darius rotor. As you can see, its construction is simple and the rotor design is also very simple. This is an example of a horizontal axis rotor. Horizontal axis rotor is predominantly used in power generation nowadays just because of their efficiency. Wind turbines convert wind motion into electricity. There are five main components: the rotor hub and pitch assembly, rotor shaft and bearings, gearbox, rotor brake, and the generator. The rotor hub and pitch assembly. The hub connects the rotor together, and the pitch assembly allows the rotor to be sped up or slowed down to generate more power or to protect the unit from extreme winds. The rotor shaft and bearings connect the rotor hub to the gearbox. The gearbox increases the speed of the rotor shaft to drive the generator. The rotor brake holds the shaft and rotor in place for servicing. And finally, the generator converts mechanical energy to electrical energy. Relevance to engineering design and practice. In solar energy, improvements in materials and manufacturing could increase efficiency of solar cells. More accurate tracking of the sun as it travels across the sky can further increase the efficiency. In wind energy, better blade design would improve performance and durability of wind turbines. More accurate weather modeling would further increase output and reduce maintenance costs.
Engineering issue of solar power, technology and efficient. More efficient solar panels tend to require higher technology and cost. The most efficient commercially solar panels on the market today have efficiency available rating as high as 22.5%, whereas the majority of panels range from 15% to 17% efficiency rating. Weather dependent. Although solar energy can be collected during cloudy and rainy days, the efficiency of the solar system drops. At nighttime, when the sun makes its daily round across the globe to provide other areas with sunlight, solar panels also go into sleep mode. Battery solar power system cannot work at night. so batteries play a big role to store the energy. Batteries in solar applications have not to meet the demands of unstable grid energy, heavy cycling, charging and discharging, and irregular fully recharging. The capacitor and efficiency need to improve. Associated with pollution, there also are some toxic materials and hazardous used during the manufacturing process of solar photovoltaic. The trouble with solar waste, solar panels often contain lead, cadmium, and other toxic chemicals that cannot be removed without breaking apart the entire panel. Responsible solar panel manufacturers will ensure that the chemicals used in the manufacturing process are handled properly. Engineering issue of wind power. Building transmission line is major issues. Distribution line collect electricity generated at the wind project and transport it to larger network transmission lines where the electricity can travel across long distance to the location where it is needed. Cost and technology. Wind power is more expensive and require higher technology from old established power plants. Like a mechanical system, wind turbines produce some noise when they operate. As wind turbines have become more efficient, more of the wind is converted into acoustic noise. Wind turbine manufacturers need to research methods of minimizing sound levels. Safety for neighborhood and environment need to concern. An, an additional concern associated with wind turbines is potential interference with radar and telecommunication facilities or electrical generating facilities. Wind generators produce electric and magnetic fields. Constructing turbines and wind facilities is extremely expensive. Wind energy development would require building transmission facilities to connect wind facilities to the existing electrical system and also could require upgrading existing electric transmission facility to allow such connection. New technology need to lower cost, increase reliability, and energy reduction, so regional deployment issues. Design for look. A good solar installation will take looks into account. Customers might be willing to have less than pretty things done to their home, but an ugly installation will lower the house value, annoy neighbors, and damage the perception of solar technology. Designed to last. Ensure component guarantees are appropriate for the installation. Understand failure points and eliminate them as possible. Follow local codes to ensure that the system is built appropriate for its geographic location. Designed to be maintenance friendly. The solar system should be designed so that there is enough room to perform work safely. From time to time, there will be a need to remove a panel and set conduit. or work with other common components. Smart design will ensure workers can perform work safety. Design for environment. There are many environmental factors that need to be addressed when installing solar panels. These include elements on the roof as well as wind, seismic activity, and sun level. Labeling your system. It's important to understand which labels will be required. The National Electrical Code, International Building Code, International Residential Code, and other standards provide helpful guidelines for installing solar systems in a safe and efficient manner. Standard National Electrical Code NEC. Wind power best practice and standard. Scalability. As global energy demand, the ability to scale is essential for effective and productive wind farm operation. Ensure that wind turbine structures have an appropriate medium level of protection against damage from hazard during the plant lifetime. Community engagement. Having a community on board and support wind power. Temperature rating. Power consumption directly relates to temperature rating, which in turn can impact reliability. Ease of use. Wind power operator should select industrial switch ready to use out of the box that require little if any configuration work. Advanced management tools VLAN support, overlap VLAN, quality of service help to improve wind power operation by providing ease of configuration and management and real-time access to key network data. Fourth, wind turbines vary in height. The height of these structures make wind turbine safety a challenge. When exposed to fall distance of 6 feet or more, must be protected from falls by using guardrail system, safety net system, personal fall rest system, cranes. Cranes are used during the construction and maintenance of wind farms. Cranes should only to be operated by qualified workers with the right documents and training. There should be routine inspections before and after its used to ensure wind turbine safety. Do not move loads over worker. Keep workers informed. One of the main issues in turbine safety is a lack of communication between management and underground workers. Electrical safety. Employees who are working directly on the electrical equipment, for example, will need to do all they can do to ensure electrical generation has stopped. While this industry is rapidly growing and work needs to be done as efficiently as possible, it is never acceptable to overlook safety. And for those responsible for the permitting process to clarify the standards that have been used in the design process and should be applied when assessing wind turbine structural capacity. Standard National Electrical Code NEC.
Wind power environmental impact includes land use, wildlife and habitat, community impact, and global warming life cycle emissions. Direct land use for wind power. It is estimated for residential systems that the area per megawatt production is roughly 3/4 of an acre. Although these wind farms take up a very large area of land, it does not necessarily utilize all of it. The spacing has a large effect on the amount of land used. It's a rule of thumb that the wind turbines should be spaced out accordingly to the rotor size. If your rotor is 90 meters, you'd want the next wind turbine to be 7 times the distance apart from it, which would be 630 meters away. As we can see, a wind farm will require large amounts of land. With the construction of more wind farms every year, they are establishing ways to utilize the land that is not currently being utilized between and around the wind farms. One of the best forms for utilizing this land will be agriculture farming. These agriculture farms have very little effect on the turbines around them due to the size and height of the turbines. At the same time, they will produce crops for humans. Wildlife and habitat impacts caused by wind farms. The largest impact these farms have on wildlife affect birds and bats that are traveling through the farm. The rotors cause different wind variations and can affect the flights of these animals. Although there are deaths accounted for, the National Wind Coordinating Committee performed a study on the impact these farms are having on bat and bird populations. Although the deaths of these animals are tragic, the NWCC does not believe it will affect the population levels of these animals. One thing they have accomplished is realizing that during low wind times, bats prefer to fly. And these rotors that are still on during low wind times produce a little electricity and cause a greater number in bat deaths. Because of the financial reasons and the impact on the wildlife, most wind farms shut off their rotors during the low wind times. Community impact caused by wind farms. There are no known negative impacts of these farms hurting our individual well-being. There are, however, multiple complaints involving the large turbines. The sound and visual impact is from the large mechanical sounds on top of the generation of noise caused by the rotors cutting through the air. The visual impact is caused by the shadow effect of the blades and also the visual effect these enormous machines have on our landscape. Life cycle global warming emissions. The actual generation of wind energy does not contain emissions, but the production of the wind farms do. Although the production does create emissions, comparing it to other fossil fuels, there's a big difference. The estimated wind turbine life cycle global warming emissions are between 0.02 and 0.04 pounds of estimated carbon dioxide per kilowatt per hour, versus the coal-generated electricity have a 1.4 to 3.6 pounds of carbon dioxide equivalent per kilowatt per hour. Solar energy's environmental impact includes land use, wildlife and habitat, and life cycle global warming emissions. Larger utility-scale solar facilities cause the land and the habitat to be lost. Depending on the size and the intensity of the solar source, photovoltaic systems range between 3.5 to 10 acres per megawatt produced. And unlike the wind farms, this land cannot be used for other things. As you can see in these pictures, the land utilized by these systems have become void. Comparing the life cycle global warming emissions of solar energy compared to coal-generated electricity emissions or other fossil fuels is very similar to that of wind. Some of the advantages and benefits of renewable energy use include less global warming, improved public health, energy sources that cannot be exhausted, jobs and economic benefits, stable energy prices, on top of being reliable and resilient. In the US, it is estimated that 29% of our global warming emissions produced are from the production of electricity. Most of those emissions come from the burning of fossil fuels. Even when we consider the life cycle emissions caused by renewable energy will produce minimal emissions that negatively impact the environment compared to that of burning fossil fuels. Natural gas plants and coal plants, on top of other fossil fuel burning, is linked with breathing problems, neurological damage, heart attacks, cancer, and a long list of serious problems caused by the air and water pollution they emit. When it comes to alternative energy, the emissions are drastically lower, and the effects these emissions have are next to nothing. Fossil fuels are being drained at a drastic rate. The more we burn, the less we have. With this in mind, the sun, the water, and wind are resources at our disposal that will not run out in the near future. This will create an endless supply of energy. Fossil fuel technologies are largely mechanized and capital intensive, while the renewable energy industry is more labor intensive. The installations and maintenance with solar and wind farms involves humans who need to install and maintain them, on top of the production of equipment being utilized with these energy forms also form a large industry and economic benefit all around. The initial startup price for these facilities is fairly expensive, although after the startup price, it becomes cheaper and more reliable because the fuel being utilized is free and abundant. When dealing with fossil fuel generation, the consumer price can drastically fluctuate due to the price of the fossil fuels being used. The common form of systems being used for alternative energy tend to be more reliable and resilient. With a combination of a distributed system, meaning they're spread out over a large area, and a modular system, which means it's composed of multiple individual units, either be wind turbines or solar arrays, these systems have less chance of crashing due to weather or other things, while fossil fuel generation is not as reliable. During Hurricane Sandy, New York and New Jersey were without power due to the fact that Hurricane Sandy damaged the fossil fuel generations.
Resort to learn more about topic. The American Solar Energy Association, the Solar Energy Industry Association, the American Wind Energy Association, Wind Technical Standards Committee, Wind Workforce Standards Committee, Wind Environmental, Health and Safety Standards Committee. 5 questions to the audience. What is the best alternative energy? What kind of renewable energy will have more impact in the future? Do you think green energy can replace fossil fuel energy in the near future? Would you prefer to see more wind farms or solar energy systems utilized in the future? What can you do to support renewable energy?